So if you have a problem with that, or you need to hide your face for other reasons, now's a good opportunity. But the police won't get it, for a couple of minutes, Still got time.
Yep, it's recording.
Awesome. Okay. Welcome everyone. So this is being recorded. We're doing an online hybrid one tonight. So yet again, you need to run away because you might see your face. Now's the opportunity. And if you're not here for Azure, that's unfortunate. You get to hear this anyway. If you are here for Azure, good news, you're in the right spot. Welcome to Brisbane Azure User Group. We are in August, so I just had like a freeze moment. Did I update that slide? Apparently I did. So happy days. Wrong year. Before we get into the updates this month, big shout out to our sponsors. So without Codify and Microsoft, this could not be possible. So thank you very much. These guys are great. Codify are awesome. Reach out to them if you want any help with Azure. Those guys can absolutely help. They're awesome people too. This is a community group, so we're keen to hear from everybody. If you have something to share, we really want to hear from you. And getting involved is super easy. All you need to do is let us know. We've got an email down the bottom there. We've got a lineup for almost the rest of the year. In years gone past, we try and do like a December unconvention. I'm saying a lot, and I shouldn't. We're doing a December unconvention night where we have lots of people that are doing little tiny bits. So if it's your first time presenting, now's a good time because you can just get up, talk about one little thing, something simple, something awesome like app service. My favorite. I tell that to everyone who wants to listen. App service is great. Front door used to be great. Front door used to be amazing. Now it's just good. but it's very secure. It's a little bit of trade-off between classic. Sorry, that's my own world. Apologies to drag everyone in. We've got a few updates, and then I'm going to hand over to Bernie. So Bernie's got an amazing presentation, and I can fully vouch for what he's going to present because I used to be the hardest holdout on Bicep. Now I'm all in. And I'm even going to the gym. So I'm that far in. Azure AD. If you haven't heard, Azure AD doesn't exist anymore. So sorry. It's now called.
Would have been renamed X.
It is. This is the new X. This is Entra. It's not quite as catchy as X. But you're right. This is the Twitter rename of Azure. I believe we actually beat Twitter to it. Yeah. So that's on them. But Azure AD is now Entra. There's actually a preview portal that dropped recently. I don't have a slide for that, but I'm going to just hook it onto here. It's looking pretty cool. You can see a lot more information in that Entra portal. So it's in preview. Check it out. So that's the exciting news. Now for just a bit of housekeeping. We got cross-region global load balancer. So for all of you that have seen some of the things like front door with the Anycast IPs that allow you to pick up an entry point globally and route to the appropriate place. Well, that was for the layer 7 stuff. Well, this is for your load balancing here. So you can now pick up those Anycast IPs in your Azure load balancer solution and take advantage of that. So lots of opportunities if you're kind of doing that sort of stuff. It's pretty good. If you're doing web, front door is still the way to go. This is for those non-web use cases.
Could you use traffic manager?
Well, like that's a good point. So Ray sort of said, could you use traffic manager? Absolutely, you can use traffic manager. So traffic manager is a little bit different in that it doesn't have that low latency failover capabilities. So front door and this one here, a lot of similarities at a high level. And it's all about that immediacy of failover. It's not the DNS based. So it's moving off from that DNS. I get this wrong, and I apologize. It's to a lower layer. Is that right? I don't know. But it's more IP based rather than that DNS and waiting for that DNS. Yeah. So it has a little bit more performance. Like there's trade-offs between them, but has a little bit more performant response. But absolutely, to your question, you could. Absolutely, that's not a bad thing to do. This just gives you a little bit more responsive, immediacy in those failover scenarios. So it's a good option. Did I miss one? Sorry. Yeah, no, that's good. Dedicated host resize. So we've got a few available on the DSV3 type 1 to type 4. It allows you to move between those sort of types. So it takes a lot of that hard work out of it for you. I mean, you could always do it manually. Absolutely. We're not saying you can't. This is just an easier option. So it's all about making this a little bit less painful. You can pick it up and use it a lot easier. It's a pretty good option if you're trying to resize those VMs. Stream analytics. Stream analytics is pretty cool. It's been around for a while, but there's a new kind of no-code editor available now. So it's a little bit friendlier. You don't need to be a developer to get some of those analytics, filtering, grouping, all those sort of core functions that you may have previously done in code. You can now do it in this no-code editor and get similar sort of outcomes, but just in a more user-friendly, low-code way. I don't normally pick up little tiny things like this, but because Dan's such a fan of APIM, I just wanted to throw this one in. APIM has got now an OData. You can pick up OData feeds, and excuse me, you can now map that and expose that through APIM. So OData is a pretty cool technology. It's been around for a long time, and now APIM can pick that stuff up for you. So that's pretty cool. So crash consistent VM restore. That's a mouthful, isn't it? What is it? It's about your disk you've got attached to that VM, and it's trying to create a consistent restore point across all those disks that allows you to restore all of them in a consistent state. Pretty handy. Operating system agnostic, so Linux, Windows, doesn't really matter. And it's going to pick those things up at a point in time, and they're going to be consistent across all of those disks that you've got connected. Pretty cool. Burstable VMs. If you've got VMs that are potentially over resourced, well, this might be something that you can use. What it does is you can basically store credits over time. And if you have a burst traffic sort of job on that VM, you can now leverage some of those credits to store. You can't store credits forever. It's not that good. There's a certain threshold that you can store, but it does give you a little bit more flexibility, and you don't have to provision them as aggressively. So it might be an opportunity if that's some sort of workload.
Didn't we already have that for a long time with these?
So we have had, not that long ago, I think it's this year, I'm pretty sure it was this year, we've had other burstable.
Yeah, so yeah, we have had it for a reasonable amount of time, but this is V2.
Okay.
I didn't know you had EPYC AMD processors. I didn't know they existed in 7.7.
They weren't available in these. Yeah.
Managed Lustra. So Lustra is like the file system that you want to attach to a HPC cluster. So it's got a high performance. It's a I thought I'd click that slide. So high throughput. It's really good. It's like a open source, I believe, technology. So now you can actually grab that and integrate that into your HPCs or other workloads. So Kubernetes is I believe, possible to hook this into. It's just gone GA. So it came out in preview, I think it was like about 6 months ago. But now that's GA, so good to go. We've got hot patch on VMs. So Windows Server VM desktop experience. So there's like the core experience, there's the desktop experience. I think the core experience already had this. This has now come to that desktop Windows Server Edition thing. So what is this? It means you're not rebooting your servers as much. You can apply these patches as it's running. So it's pretty cool. It's now available. Feels like this is going on forever. Customer managed failover in ADLS Gen 2. So you can now initiate the failover of these storage accounts into your other regions. So rather than Azure doing the monitoring and automatically doing that for you, if you so choose, you can now initiate that, so you can get more control over what's going on. That's gone into preview, not GA. All right, and Dan has promised that he's got a few surprises for me, which is great. It seems to be integration down under.
If you're interested in the integration space on the Microsoft stack, we do a monthly webcast that's run from here in Australia, so it's a little bit more friendly time zone than the ones that are run out of Redmond. So that's going on. So this month we got this coming up. The speaker for this one's a bit dodgy, but the topic's a good topic. So if you hopefully he doesn't.
That's not Dan Toomey, is it?
Must be. I'll join us next Thursday night.
Next Thursday. Tune in. All right, cool. Some resources we always talk about. So we've got the Slack team, we've got the YouTube channel, and we've got a couple of learning resources. These slides will be up, so you don't have to. Sorry, I could go slower if you want to grab a screenshot. So these slides are going to be posted.
Probably tonight. Yeah.
Probably tonight.
Just meet up. Chat.
And if you look at the older slides, they're exactly the same. So that's another part. There's a couple of blogs that we think are pretty cool. And yet again, it's the same content as for a long time. But without any further ado, I want to hand it over to the master of Bicep, Bernie White, the person that changed my world and moved me from ARM finally to Bicep. It's amazing technology. Now, Bernie's a cloud solution architect at Microsoft, and he's a really approachable guy. So if you have any trouble, he's always been there to help me. I'm sure he's going to be the same for everyone else. Thank you.
Are you going to use the presenter mouse?
No.
Yes. I see.
Awesome.
You're sharing your.
Cool. Wow. Welcome, Brisbane. Yeah, so today we're going to go through infrastructure as code patterns with Azure Bicep. I've got, some slides, some demos, but really just feel free to ask questions and participate and enjoy the discussion, right? So as Damien said, I'm Bernie White. I'm a cloud solution architect. I do quite a fair bit in the DevOps space and the infrastructure as code space. So probably as customers, you may have seen me on site at some point. If you haven't, possibly you will in the future. My LinkedIn profile's there, and one of the projects that I work on a fair bit is an open source project called PS Rule, which helps you validate code from a DevOps and well-architected cloud adoption framework type mindset. So that's a tool that then you can also check out as well if you're interested. So, like pretty well is the what everybody does these days and what you do at work as well, we're going to ask Ben. And in this particular case, what is infrastructure as code and how should I use it? So the report from Bing, or the results from Bing, gave us some pretty interesting results. And, for the most part, they're pretty accurate, right? Interestingly, most of these are Microsoft sources in terms of the references and things like that. But I mean, there's some good stuff there. So I guess call outs would be, well, it helps around consistency and reproducibility, right? Pretty important. Human errors and manual tasks to reduce, right? So pretty awesome. We'll go into a little bit more detail, but infrastructure as code, hopefully, if you haven't already within your organization started hearing about infrastructure as code or doing infrastructure as code, then you're maybe at least starting to think about it, generally speaking, and hopefully tonight you might get some benefits of why you should at least take that back to your organization and start asking questions about it. In terms of security benefits, right? So infrastructure as code also has some security benefits. Like everything, there's also challenges too, right? But definitely from a repeatability perspective, like we mentioned, when we start to have infrastructure defined as code, then we can then start to leverage some of our existing investments, such as GitHub or Azure DevOps or any other tool chains that we might have that work in the application code space. We can start to not leverage all of them, but quite a lot of those to actually make our infrastructure more secure as a result too, right? And so, again, preventing misconfiguration, particularly when we extend that to patterns, which is the topic of tonight, but also then, more importantly, the DevOps collaboration. So it definitely starts to then help allow multiple participants participate on building infrastructure, right? In times past, that might have been somebody, in a data center playing around with a rack and then actually going and configuring a network switch or something like that. Obviously, in the world of cloud, then everything's infrastructure as code. We can actually see what the change is before we actually commit it by basically describing that change in infrastructure as code, right? So then we get collaboration and also security ownership, right? Of course, just because we've got DevOps or we start to move in infrastructure as code doesn't mean that our security, our network, and our infrastructure people just instantly talk to each other. That's obviously something that we need to work on as a cultural thing. But from a tooling perspective, it gives us the option to enable that. Cool. So what is Azure Bicep? Assuming that you don't know anything about Bicep, then it's an infrastructure as code language that allows us to effectively describe our Azure resources. So I'm talking such things as our networking, our firewall configurations, our storage accounts, our virtual machines. It could be our app services for Damien's benefit, or our functions, or our Kubernetes clusters. All of these things can be described, and also things like databases and things like that, right? It doesn't really deal with the data aspect of it. So when we're sort of defining a database, then that would be the configuration of the database server and that the database exists, but not the content of the database, such as your records, right? So who should be interested in Azure Bicep? And really, anybody that's responsible for checking, reviewing, or changing any configuration, right? So already we're sort of starting to think, okay, well, does that sound like a change process, right? Potentially, yeah, it actually involves part of that. And so, typically this then might involve, network security, DevOps, platform engineers, and developers, right? Cool. So let's jump in. Cool. So we've got our Visual Studio Code up, ready to go. And so let's just pretty well get started and actually start typing out some Bicep code. And so I'm pretty well to get started. Visual Studio Code is definitely the way to go. You can also go ahead and deploy it into, I believe, Atom and Visual Studio as well. But Visual Studio Code's free, open source, and it's something that we can easily deploy, and it's a great experience. So from that perspective, all we need to get started is basically this Bicep extension, which you can just install by basically typing in here and finding Bicep and then hitting install. If you are behind a corporate proxy, there is some additional proxy settings that you may need to configure as well. But apart from that, that's pretty well it. And then from there, we can go ahead and create .bicep files. And so Bicep actually supports two file extensions, Bicep and Bicep params. And so both of those files can be used. But as soon as we basically go ahead and create one of these files, then we can get some of the Bicep syntax completion, right? So if we want to go ahead and create a storage account, there is a number of different pre-built snippets that we can use. We can obviously go ahead and fully complete that as well, which I'll do in a sec. And then basically we effectively have start to have our definition of that storage account, of that resource. Similar thing for a network. I may start with a network. It's VNet. Cool. So we've got our virtual network there. The first part is we need to give it a symbolic name, which you can sort of see is automatically populated there from the snippet. You can change that to be something else, such as VNet 001 if we want. And then we have a description, and this relates to more the Azure resource type, so the type of thing that we want to deploy. And so there's obviously various different things that we can set there. You can go ahead and look at the documentation. Alternatively, you can also go ahead and you type in resource, we do VNet 002, it will actually go ahead and build up a list that we can type. So if we wanted our storage account again, we can go ahead and find it. And then the next part of it is basically the API version. So as you can imagine with Azure, on a regular basis, some resources more regular than others, we release feature enhancements and things like that. And so each of those feature enhancements is basically manifested as an API version. So you basically say which version of the storage account you want to use or the virtual network, and then you get those features, right? And then in maybe a year's time, if you decide, hey, there's a new feature that Microsoft just released that I'd like to leverage, then you would probably just need to target to the latest version that includes that feature. Right? Apart from that, then we've got the name. So what do we want to call it? So again, I'm going to stick with VNet 001. The location. So this would be the Azure region we'd like to deploy to. So you could go ahead and just type in there Australia East. In this case here, I'm going to save myself a little bit of trouble, and I'm going to create a parameter called location, which is the type of string. And then I'm going to make that Australia East, because that's the region I'd like to deploy to. And so that would be the same as that. Alternatively, I can also go ahead and just automatically pick up what location the resource group's deployed in. So if the resource group's already deployed in Australia East, it'll just automatically deploy the resource there as well, which means then, especially if I'm an organization that has maybe multiple regions in Azure that you want to deploy to. You don't really need to make changes to this file. You just, when you deploy it, you choose where it's going at that point in time, right? And it will just automatically fill that up. Cool, then we'll choose our address spaces. I'm not going to bore you with the details of the networking from address space, but basically we've got all these additional properties that we can go ahead and set. And then we've got subnets as well, right? Again, they've got more properties. We can go ahead and, let me just turn on screencast mode. If we go Control-Shift, Control-Space, then that'll also auto-complete based on what properties we have. So if we wanted to go ahead and throw in some DCP options, we can go ahead and do that too. And then we might go ahead and throw in now, 10. One address, probably not, but let's go with 4, right? And away we go. If we start to make mistakes along the way, so maybe we go ahead and put in something like that comma, and then we go ahead and do that. You'll sort of see, obviously, we get the benefits of syntax highlighting and stuff like that. So from that perspective, instantly we've got some feedback about what's going wrong from a Bicep perspective. So essentially, we can go ahead and populate our whole infrastructure with something like this, right? So there's a few little different tricks as well that we can use, which I will show. But now, let me jump across to something. I may not have it already open, but let's go ahead and.
The Bicep is its own language, is it?
Bicep is its own language. Yeah. If we go in here, then like an example might be, okay, if I go in here, here's my resource group within Azure that then deploys my storage account, my key vault, and various other things that then might be deployed in that environment. So this ends up being what it looks like. And so we get some benefits here, like instantly you can sort of see, hey, we can do comments, right? We can actually document our code as we go through. So it's actually clear. So from a consumption perspective, then obviously, looking at code, if you're not familiar with code, then hey, that might be a slight challenge. But when we start to leverage things such as good parameter names and comments, then even if you don't feel comfortable writing the code yourself, then often you can understand what's happening, right? So from that perspective, obviously that's a big pro. So we'll come back to that, but let's go back to our Bicep patterns. And so if you've previously looked at infrastructure as code within Azure, then primarily you had 2 other options previously. There was ARM templates, which you don't really need to know about these days, but effectively that would look like that, and that's, horrible. It's not that long considering we only have 1 VNet, but it's horrible enough. So we can just forget about that. Or you could go ahead and leverage something like Terraform is another language, again, which that gets used. And in terms of the hand across between something like Terraform and Bicep, very similar. They obviously have their own syntaxes, but a lot of the use cases and how you leverage them is quite similar, right? But again, in terms of languages, from an Azure perspective, we support both, but really Bicep is really the first party language that just targets you, right? So that's where it's situated. So we can go ahead and build out our Bicep files for whatever infrastructure we like. And then we do have the benefit of checking that into source control or anything like that, and then doing peer review on it, again, for our change process. And then within our tool chain that might exist within Azure DevOps or GitHub or whatever tool you're using, then you can implement like approval process and stuff like that. So you can actually have a proper change process that then is that's automated end to end, as opposed to one that has so many manual processes involved. And also when you actually go to implement, there's a difference between what you planned and what you actually implement, right? This keeps it all in one spot. And again, there's no real limit on how many files you can go ahead and create. I can go ahead and have another file here for storage .bicep, And again, I can go ahead and put more code in there, right? We'll show some examples on that in a sec when we look further at patterns. Did anybody have any questions? And let me just double check the remote participants as well and see if there's anything.
Sam's been answering questions. Good.
Sam's been answering in the chat. Awesome. Fantastic. Cool. So let's jump into patterns. Sorry, was there a question? Sorry.
Yeah, that's right. How did you create that JSON file you said when you built it?
Oh yeah, great question. Yeah. So again, we don't. It's sort of like one of those things that we don't like to look at JSON like that much. But if you want to, then by all means, you'd basically right click and go build ARM template, and then it will effectively do the build. So essentially what's happening on the back end, and again, you may or may not care too much about the details, but the Azure control plane, it's called Azure Resource Manager, or ARM for short. And so this is basically a set of microservices, and it speaks JSON, right? So really, Bicep is just a more human-friendly like language as opposed to JSON, but then it also has all the IntelliSense and things like that that then make it much easier and faster to develop for than JSON on top. So effectively, we convert that or transpile that to JSON before it gets sent. In terms of practical use case, you don't really need to know about it because whenever you go ahead and deploy, the Azure tooling automatically does that process. So you don't really look at JSON files, but you can have a look at them if you want to.
Your Bicep's always converted into an ARM JSON template where it's used to create all the infrastructure. Is that right?
Yeah, so it converts it to JSON, but it doesn't necessarily even create the file. It just does it in memory and sends it. Yeah. You can't create an invalid JSON though from Bicep. Whereas previously, you configured. That's right. That's right. So yeah, so the syntax highlighting and the language component that exists within VS Code basically gives you compile issues or red squigglies if you're doing something wrong that won't compile. That doesn't necessarily mean that you can't try to deploy something that won't work in Azure. In terms of maybe you've got an Azure policy that blocks that, or maybe you've tried to deploy to the Antarctic region, which doesn't exist, right? So those still are like basically deploy time issues that you may encounter, but a lot of the issues that we saw with ARM templates sort of disappear because a lot of them are common syntax issues, such as I forgot a comma at the end of the line for JSON and now it won't build, right? Sam?
I was just going to say another cool feature is if you right click on that main.bicep again, is I use one all the time is you can actually use it to generate parameter files. There's a section under build ARM template, and it'll give you, if you click on that, it then gives you the option for a Bicep parameter or an ARM parameter. So you don't know what inputs need to receive, you just click generate.
Yeah, so hopefully you heard that on the remotely, but basically Sam was just sort of saying that then you can also go ahead and right click on the main or the Bicep file and then generate parameters. So so just like we sort of have here now, we actually now have a parameter, right? So we've defined a location parameter, which then allows us to then at a future time define what the location is. We can do that with pretty well everything, right? And so you may then want to have different parameter files for different things, right? So as an example, maybe we have a param for environment, right? Pretty common case, and pretty common case that then you're going to want to change that at a later time. So if we go ahead and do tags, something like that, and we create an env tag, we can then set that to the env parameter. And so then when we go ahead and deploy, we would then just specify this is the environment that we're deploying to, such as dev or UAT, right? And so we could go ahead and generate a parameter file, such as a Bicep param file, and then only include required parameters. And then we could go ahead and have this parameter file could be for dev, right? And then we could set that to be the dev environment, right? And then obviously we could do the same thing for prod or whatever, right?
Other than adding more Bicep files, is there any way you can have like a collection of standardized files and then include them into? So you're saying, oh, I'm working on this particular thing, but I want to pull in our standard company-wise kind of storage policy or VNet policy. Is there any way to do that?
Absolutely. Yeah. So the question being, can I have maybe some standard patterns, let's call them, that then we would then pull in to our deployment? Absolutely, right? And so that's the cool thing about that. And the cool thing about parameterizing some of this stuff is that we can then start to define, okay, well, what does a virtual machine look like? You've probably got hundreds of them in your organization. What does a database look like? Again, you've probably got at least tens, if not hundreds of those too, right? So we don't really need to have every single person define what a database is every single time. They often just need to change simple things such as, you know, how much capacity or what SKU do I use, right? Or what's the name of it? Potentially what location it is in. Is it in different environments? But they don't necessarily need to completely redefine what a database should be for your organization each time. So that's where I guess the patterns comes in. And so in terms of Bicep, that's called a module. So we can basically build a module, which is essentially the file that I already built. A module is effectively just a file with parameters. And that's sort of how simple it is to get started. But I'll show you a few models that then helps that scale across an organization too. Cool. Let me just double check the chat again, but looks like we're good. In the chat, there's, you know, it looks like much better than depends on. Handles depends on so much better. Yep, absolutely. Wayne?
Might want
Yeah, go ahead.
a way to
Yes. So the question was, is there a way to migrate ARM templates into Bicep? And I will show you that, but I'm going to do it a little bit later. Cool. So Bicep patterns. So why build a pattern, right? Obviously, you know, by its name, you know, maybe we want to have consistency, like we mentioned before. And so, again, pretty good chance that then across an organization, that then you're going to be rebuilding the same thing. In a startup, again, you're probably still going to be building a storage account multiple times, right? There's certain things that are going to be high use, and there's probably going to be other things that are low use. But certainly in an enterprise environment, you're probably building quite a few of many different types of resources. So it absolutely makes sense to build a pattern for consistency's sake, so that it's a similar pattern across the organization. Again, we can still have parameters for where there's differences between those. We can also, again, if we're scaling this to an enterprise, then we can also then start to unlock SME knowledge, right? So maybe I've got a security engineer and then a networking engineer and a developer, and possibly the developer may not necessarily have all the networking skills, but together with the networking engineer, they can obviously make that happen, right? And so obviously if we have a pattern that then people across our organization are collaborating on, and then you're going through an approval process, then obviously this allows us to tap into that knowledge, but then also from a governance perspective, it allows us to accelerate that, right? Because once we actually have agreed on this is what we're doing for any of these types of patterns or these solutions in the future, then we can basically accelerate that through a change process. We don't need to go ahead and do a full review every single time. We can just do a light touch review, right? Have you enabled the specific things that we needed, or has anything changed from the pattern that then we need to adopt because of this vulnerability or this configuration requirement that now exists for this application? But we can do it in a much light touch path. We don't need to necessarily wait for, you would think that then in the days of cloud, that then change processes are magically fast overnight. Turns out they're not. Again, customers still struggle with challenges around it takes 2 or 3 weeks to get something through a design review board and things like that. So from that perspective, this offers, if we're using a standard pattern, it doesn't completely remove that component, right? Because you should still have good design architecture discussions, but it accelerates it because we're using a standard pattern. And then if a business unit or an organization or a team decides to use, hey, we're going to use this accelerated pattern, or we're going to use this pattern, then that obviously allows them to move faster and more agilely. And people that are building new stuff then might have to go through a slightly longer process, right? Cool. So what makes a good pattern? So typically it's opinionated, right? So we don't want to go ahead and build a pattern ideally that's super generic, right? You know, at Microsoft, we obviously have a requirement where we need to cater for all customers. But when you're building your own modules or your own patterns, you don't necessarily need to provide all possible options that then might exist, especially the ones that are clearly insecure, right? So you could have a parameter that says allow access to use TLS1, but you shouldn't, right? Unless you have a specific business requirement that says, hey, we've got this limited use case that then requires this application to have that feature, right? Similarly, you shouldn't, you know, allow access to public endpoints apart from maybe that specific use case where you do, right? So generically, across your patterns, think about what makes sense for your organization, what aligns to the goals of your organization and the security requirements for your organization. Don't build a pattern so generic that effectively you've just re-implemented all the parameters that then the resource exposes anyway, right? Avoid bleeding through internals of Azure. So we don't necessarily want to make it as complex as the resource description behind. Again, Microsoft is trying to cater for all the customer scenarios that might exist. But you know, we don't necessarily need to, you know, expose or show that or force somebody to configure all those things every single time. So again, we've just got to be sensible about if you were consuming this pattern, what would you require and how would you like it to be? And actually, when you go ahead and do things like testing, you can actually prove that it's actually easy to consume or not. And if you find that it's not easy to consume, then that's a good flag to sort of say, okay, well, do we really need all these parameters? Or can they be optional instead of mandatory, right? Reusable, so obviously the whole intent is that we want it to be reusable, but obviously we've got to strike that balance between generic and reproducibility. And then tested and documented. So again, an advantage that we're getting by building infrastructure as code is that then we can use some automated processes such as documentation and automated testing as well. So you know, that obviously improves our security posture in general, but also then it should help pick up issues that then don't require a human to be involved. We're still doing things like peer review, right? So somebody still should look at the code, be comfortable with the code, and you should still have architecture discussions, right? But instead of, you know, like little mistakes getting through those and then having to waste time on reviewing something that's not ready, then you should be able to pick those things up in tests. Okay. Cool. So repository structure. So often we have questions around, you know, what does that look like from an implementation perspective? I'm going to offer you two patterns. So one is called monolithic repos, and the other one is a distributed repo. So these are two common patterns. There's probably variations of them that you can think of, but these are probably the ones that I would sort of suggest to start from, right? And so the monolithic repo is the easiest, it's the simplest, it probably requires the least amount of complexity, which is why I've got it first. And so the idea here is that we go ahead and put our patterns and typically our deployments all in the same repo. And then, so there might be a Git repo on Azure DevOps or GitHub or whatever tool you choose. And then we basically keep everything in the same place. And so Bicep has a native way to support this that works really nicely and is straightforward. So again, it requires the least amount of complexity all around, right? And then because everything's all in one place as well, then this obviously makes it easier from a delegation of who should actually be able to review and those types of things, right? Every time you spin up a repo normally, there's some level of overhead that's required to actually maintain that properly. So obviously putting it in one makes it nice and easy. Probably the cautions here is that when you start to get large environments with then lots of disparate teams and lots of people working, then it may get hard to manage, particularly if you have project concurrency. So if you are in an organization where you run a lot of projects in concurrent, then that may not be the right solution for you, right? Just because you don't want to get to a point of where you have when you merge code into a repo, then typically you need to rebase or update branches that are also in review, and then that starts to get more and more complicated if you have lots of competing reviews occurring. Right? Cool. So the monolithic repo works pretty straightforward. We go ahead and put our pattern in a code repository, and then we use some sort of CI/CD toolset such as Azure Pipelines or GitHub Actions to go ahead and then push that to Azure. And I'll show you what the structure looks like in a sec as well. So pretty straightforward. In terms of the distributed repo, in this case here, we sort of start to take a little bit more separation. But obviously with that comes some additional complexity and additional overhead. And so in this case here, we go ahead and put our patterns, our reusable patterns in one repo, and then we might go ahead and have repositories for different application teams or different environments that then might need to exist, right? And so this, again, works well from a project perspective because then, a project has all their code in one place, right? But obviously there's additional overhead with that. And also then you need to think about, okay, from a DevSecOps perspective, that other repo, does it have the same quality control over the occurring across it than the central repo? So it does add some additional challenges in terms of consistency. It's not insurmountable or anything like that, but there is additional complexity required to do it properly, right? And then there is typically some publishing latency of new patterns. So to be able to consume the pattern needs to obviously go in the common repository where the patterns live. It needs to be approved, published out before we can really even start developing against it, right? So that may take time depending on what your review process to get a new pattern is. Some organization, maybe that's weeks. For some organizations, maybe it's days, maybe it's months, right? It really depends on your organization. I've seen some cases which then fit on all those spectrums, right? But it does support high project concurrency very well, right? So again, similar to like what we're sort of saying about DevOps before as well, is that doesn't mean just because you've got separate repos doesn't mean that it has to be a slow process again. It's about how you collaborate and how you talk and how frequent you start to actually do architecture review, right? Cool, so the distributed repo looks like this. We basically go ahead and put our patterns in a pattern repository. We go ahead and publish those to Azure. In Azure, then there's a component that we can deploy called an Azure Container Registry, or in this concept known as a Bicep registry. And basically this is where all our modules get stored, right? So for the people that are interested, then Bicep stores its artifacts in OCI compliant storage. So that's the same storage that a lot of like application containers for like Docker containers would then be stored in. So it basically uses the same specification to store these modules that then can be reused. And so once it's in the registry, then you can go ahead and pull it into any repository that wants to consume it. So it's sort of like a publisher-subscriber type model where you can then consume it across your whole environment from discrete repositories, and then they can manage their own thing, right? And then obviously to deploy that, you basically, through your build process, you basically consume all those modules, and then you basically publish them to Azure, right? With whatever parameters specified to deploy to the specific case that you have. Cool. Any questions?
With the publish subscribe model under the distributed repo, let's say you published a pattern and then it was used, and then you go, oh shit, that was a mistake. That pattern's got problems with it. I want to recall that pattern. Is there any way to do that without involvement from the distributed repositories that have used the pattern?
So yeah, so good question. So so I guess the question was, if I publish a pattern and then people start to consume it, I guess how do I claw that back or pull that back, right? Yeah. Yeah, absolutely. So Yeah, so it's a good question. So I'll answer in a few different ways. So so every time the build, so in our bottom section here where our deployment repo is then triggering the deployment, typically at that time that's when the actual patterns are pulled in, right, through the Bicep build process, which then is going to happen immediately before it's sent to Azure, right?
So you're like referencing them from the registry.
Yeah.
In the registry anymore, that reference doesn't go anywhere.
Exactly.
Okay.
Yeah, exactly. So yeah, so if you removed it from the registry or you updated it in the registry before deployment, then you're good, right? Once it actually is in Azure, then it doesn't really have any hooks back to the code that it was on. So updating the registry won't change what's in Azure, but obviously rerunning the pipeline probably in a lot of cases will, but not necessarily. Again, it depends on what the change is, right? But yeah, so if you removed it from the registry or updated it, then the next build that runs would then get the latest version, right? In terms of consuming from the registry as well, you could also look at versioning, right? So when we go ahead and have different artifacts that we want to consume across, an organization and multiple versions of that, it might also be a great idea to go ahead and publish the artifacts in a versioned manner as well. So people can maybe they don't necessarily, maybe if you deployed out a breaking change, you might want to make sure that then you've got the ability for people to move to that breaking change, as opposed to sort of say, well, all your deployments are broken until you fix that, right? So yeah, that's basically it. Cool. Let me just double check and see if there are any questions in the chat that Sam has not answered. Yep, so parameter files support references. So yeah, so Dan answered that one. So so some of the questions were, how do we handle sensitive data, right? Obviously, we've got a file. We don't want to put a clear text password in the file, right? Because then anybody that then has access to that file, which will be anybody that consumes that repository, now and in the future, right? Because once you commit something to a Git repo, it's in history, right? Even if you delete it, unless you completely destroy the history and change that and remove it, it's there. So yes, you don't want to store passwords in there. And so Bicep allows you to reference any sensitive data from an Azure Key Vault. So again, this is a fairly standard model. So for people that have done that before, it's probably not too much of an issue. But basically, the Key Vault is a encrypted store. And then when Azure goes to do the deployment, so we sort of mentioned, going back to this slide, when the pipeline executes, this is what's going to basically be building that Bicep file and pulling in the modules. It will then obviously authenticate to Azure and talk to Azure. And it will basically have information in there that when you go ahead and execute this deployment, Azure automatically go ahead and get these secrets from these key vaults. So in terms of, from a security perspective, the pipeline, the deployment repo, the service principal, technically they don't even have access to the secrets per se. It's actually only Azure that actually has it. And it will then use the references that it's provided to basically go ahead and sort of pull in those secrets when it actually gets to that activity from the deployment process. So yeah, so pretty secure there.
Do you have a dividing line where you'd use a key vault as opposed to, say, a GitHub secret in that pipeline?
Yeah, so the question is there a line where you would maybe use a GitHub secret versus a key vault? And so I guess the answer here is, if you use a GitHub secret, then effectively it's exposed to the pipeline, right? Because it needs to know that before. And so Azure does have a way to, if you mark within Bicep, we'll go there in a sec anyway, but within Bicep, you can mark, just like you could with ARM templates previously, you can mark them as secret, and then Azure takes special care to basically then not expose those or record those per se. But it's still exposed to the pipeline, right? Whereas if we deployed in the Key Vault, then Azure will then use those references when the deployment gets there. So the keys are not exposed to the pipeline if you use Azure Key Vault, right?
Yeah, I think I had hassles having to deploy our own agents, so we didn't have to have public endpoints on keyboards. So that's not the same.
Yeah.
So, yeah. Thank you.
Does that work for the new az.getSecret from the Bicep for files as well?
Yes, it should do. Yeah. So basically, there's a let's make a point to show that. But basically, you can use getSecret to basically go ahead and pull in a secret, and effectively, it's using key vault references, right? So effectively, it will just compile down to the same thing as referencing a secret from key vault. Yeah.
Just going back to what you're saying before, we we're talking about the repository and updating the pattern. Can the pipelines be triggered?
Can the pipelines be triggered? Yeah, so the question was, can the pipelines be triggered when we update the code? Absolutely. So that would be related to, so basically how that would work is it's not really to do with Bicep per se, it's more to do with your CI/CD process and the tool set that you're using from a DevOps perspective. But in terms of how that would work in Azure DevOps is you'd basically go ahead and build a YAML pipeline. A YAML pipeline then has triggers on it, and it basically one of the triggers is a push trigger or a commit trigger. So anytime that branch changes, so when we go ahead and do our pull request, so we do a change, we create a pull request for peer review, that then gets approved and gets merged. That then will add on to the history of our Git repository, right? And so every time we make a change, again, it's being recorded in that history and moving forward. And so when that commit occurs, then you can have your pipeline automatically fire off, hey, I need to go ahead and deploy to the dev environment now, or whatever environment that the pipeline is being configured for. Same deal for GitHub Actions. Again, it's slightly different syntax, still YAML, but same effect. And again, other CI/CD platforms or DevOps tool sets have something similar, typically speaking. Yeah. Does that answer the question?
Yeah.
Yeah.
One question in the chat, I went.
Yep.
There's a bit of a cheater to it.
Question in the chat. Is that one down the bottom?
The API management one.
APIM. Oh, yeah. How this Bicep will help in API management control between the application flow. So I guess probably definitely do a follow-up question if there's additional context, but probably the way that I'll answer that at the moment is that from an API management perspective, almost everything that you can do in APIM can be defined in Bicep, right? So obviously there's the APIM service or the gateway component, right? There will be different configurations such as maybe the identity servers that I want to use, the logging, all that type of stuff. And then there's also APIs that then are defined in APIM. Technically, you can write them all in Bicep. You may or may not necessarily want to a certain degree. With APIM, again, like Damien was showing us, it supports importing in a bunch of different formats that are more aligned to API standards, such as something like OpenAPI spec, or you can also do GraphQL and things like that. So when you import those files in, typically APIM generates some of that code automatically behind, or that configuration behind. So for some parts, you absolutely will want to do Bicep. For the specific operation or the GET request to this API, probably I would suggest, while you can do it in Bicep, it's probably better to leverage the OpenAPI spec and import that in, just because it's easier to define from your application development and API design perspective in those languages. But technically you could. In terms of flow, I guess it would basically, because it can change the APIM configuration, then that's how it would impact it. But Bicep isn't really designed for like communicating to APIs or anything like that, right? It's designed for configuring Azure resources. Cool. So let's jump to the code, right? So we've got our files, and with that for now. We also mute that. And then so we've got our files. So to create a module, again, typically speaking, when you sort of go to sort of say, hey, I'd like to define a reusable pattern, it's normally a probably more like specific objective, right? Or you could go ahead and build some code and then go to say, okay, well, now we want to make that reusable, and then you maybe convert it into a module. So instead of having very solution specific things, you'd then obviously expose parameters and that type of stuff. In this case here, I'm just going to go ahead and build a Bicep module now. So I'm just going to go ahead and create a file. I'm going to use a few different VS Code tips. So let's go ahead and create our storage account. So storage v1 main.bicep, right? And then basically VS Code will just create our directory structure there. And then I've got some snippets. So I sneakily put some snippets that I use in the .vs Code directory, which is basically super easy way to basically go ahead and then make your workflow even faster than what it already is. So I'm just going to type in bicep, and then I'm going to go ahead and do my bicep module, right? And then I'm going to make it a storage module, right? And then I might go ahead and fill in descriptions such as create or update a storage account. And I won't bother with the summary, right? Let's get rid of that. Cool. So as you can sort of see, probably in most cases, you're probably going to have a name or a resource. So it's there. There's also a location. Again, you probably want this. So it's already there. And again, you probably also want tags, right? And so we'll touch on variables in a sec, but let's go ahead and maybe just put in like a secret parameter. Not that we need one for storage account, but maybe that might help. So if we go ahead and put in our secret, and that's going to be a string, you'll notice here that there's a prompt on the end when you type string, which then says, hey, would you like to make it a secure string? And if we do that, it'll basically just put this, basically this decoration or annotation attribute on the end of the parameter. So it can be technical, it doesn't have to be directly on top of it, but it needs to be like immediately before the parameter. And then this will basically make it that secret parameter so that Azure knows how to handle it and treat it with the nature of that it is. So if you do things like, hey, now I'd like to go ahead and output my secret. So we'll just call it S equals is a string, and then call it secret. It will sort of go, hey, yeah, you shouldn't do that, right? And we'll come back to that one. So let's go ahead and create our storage account. So storage accounts, right? Create one of those. We can also go ahead, because again, we've got some nice IntelliSense, we can also go ahead and right click, and you'll sort of notice down here, we've got reference to storage. We've only got one resource there. We can actually, on that note as well, if we go ahead and control click, it'll actually automatically navigate for us, which is pretty awesome. But then we can also go ahead and right click and go rename symbol, and now we can just call this storage, right? And it will go ahead and obviously update any references, right? Which is sort of the benefits that we get on top of, like, if we did JSON, this just wouldn't work. It would be horrible and it would be a mess. This is much easier, right? Because we're getting the benefits of something that understands the syntax, right? Cool. Let's go ahead and just put in a few things such as, I'll maybe just go maybe TLS. We used that as an option before, right? TLS2, or maybe we might even do one, right? Because we might also come back to that as well. So we've got our storage, happy days. So you can sort of see in terms of the structure, I've sort of started defining of, here's where my modules live. Here's what my module is called. Here's the version 1 of it. So again, in terms of versioning, there's probably a few different ways you can take it. I generally like to keep it as simple as possible. So I generally encourage customers to follow SemVer, which is basically a open standard, which basically defines how you should version, right? And so in terms of that, I generally don't suggest customers to necessarily do a folder such as v1.0.0 as in full SemVer instead of major, minor, patch version. I generally just do major version because the difference between version 1 and version 2 would then be a breaking change, right? And so that's sort of declared within the SemVer standard, right? So generally, I sort of say version 1. You absolutely can do major, minor, and patch if you want to. I would probably automate that though as part of the CI process as opposed to declare it in a file structure. Otherwise, again, it becomes complicated. And when you actually then want to compare, hey, I made this change in version 1.0.0 to 1.0.0.1 or 1.0.1, I'm even getting confused, then it becomes hard because you can't easily compare those files because then they become different files, right? So yeah, so that's it. In terms of then we should go ahead and add tests, right? So like I said before, let's go ahead and in fact, maybe let's go with that. So now let's go ahead and create a new file. So I'm going to go ahead and create a .tests folder, and then I'll create main.tests.bicep. And let's go ahead and use my snippet again, the test, right? And so here, effectively, we've strategically put our test file directly in a folder below where our main is. So then we can just do .. right? Which sort of, again, makes it easy if you keep it in the same structure. And so you can sort of see here, we've got a red squiggly, which is basically saying, hey, you've got required parameters that need to be defined, right? So, and that was, we had secret, and I think that was it. So param, and then again, you can sort of see there's a prompt here, automatically give me required properties, which it is secret, and now it's all happy, right? So there's that. Again, we would obviously want to put our secret here, but this is also a test, so it's less of an issue. But what we strictly should do is we should go ahead and sort of say, now I'm going to define a key vault, right? Which then key vault, right? Just like we would actually do nice and securely in production. And then we would go ahead and define an existing key vault instead, right? And so this allows us to reference that something already there. For testing, it doesn't really matter so much because we're not actually deploying the test, we're actually deploying our deployment that then is actually using real values. But for the sake of testing, then we can do things properly end to end, right? So now we can just call it our test vault. And over here, we can go ahead and do key vault get secret, and then get our secret, which again is also a test. So that is fine. Cool. And so then there was I think it was in the parameter file, we also have another option for secrets, which we'll cover in a sec. But so there, we've got our module, we've got a basic test. Again, from here, we can sort of see, okay, well, does this make sense? Probably no, because we've got a secret and a storage account. But outside of that, it's pretty straightforward. So where you would then start to, I guess, worry is when we start to have things like this, right? And we have basically a whole bunch of mandatory parameters that aren't necessary. If we then start to add those in and go, okay, well, we've got name, and then we've also got a name here, right? What's the deal here, Bernie? And location. Again, this, as you can sort of see, this is something fairly straightforward. It's definitely a lot more worse when you actually build a production module. If you're sort of starting to say, okay, well, I've got a whole bunch of mandatory parameters here now, then that's, again, your flag to sort of say, should we be defaulting some of these, right, for our organization?
Good question. So what's the test? Are you running anything, or are you just inspecting the?
So our test is, so our test, we can run stuff. So we can run some tooling, which we'll sort of talk about in a sec. But more specifically, we're testing to sort of see how can we consume it. And also when we go back to our main and then we go, hey, it would be great to add a new parameter, such as let's go ahead and create a new parameter called, min TLS, and it's a string, right? But we're going to make it a mandatory parameter. Guess what? Now we've broken our test, right? If you try to build it, it's going to go, hey, yeah, we don't have this thing, right? So again, it sort of keeps you honest, right? But then it's not going to detect all breaking changes, right? But it's definitely going to pick up some. And again, saving time later down the track is what it's all about, right? Cool. I guess, and so on the testing, I'm going to remove the secret, right? Let's go ahead and kill that off. So since we've got no required parameters, I think go ahead and save that, and we'll make that back to deploy resource group location, and this can be deployment name, which basically means that then over here now, done that correctly. I think that's fine. I think it just hasn't fully refreshed on that yet.
Do you need to specify the parameters even though there's not?
So yeah, so it's a good question. So do we need to specify the parameters? So basically by that would make the name parameter required, but basically it becomes optional as soon as we add a alternative value for it. Yeah. So yeah, so in this particular case, we don't need to. Why is that not building is a good question.
Yeah, what I mean is, do you need the param?
The param block, maybe that's what it is. It might just need the param word. No, that's not it. Is it saying it needs? It's got an error, so it's probably this down here, right? Okay. Cool. Now it's all happy, right? Cool. So we've got our pattern, and then so if we're doing our monorepo deal, then to then go ahead and consume that, we would then actually go down and then again in our file wherever we want to consume it, we would then say, hey, I'd like to use a module instead, and this is going to be our storage 001, and then it will basically be a relative path from wherever that file is, and again we can just autocomplete. And then required properties, and because there's only one required parameter, which is name, then we would basically go ahead and give it our storage account, storage 001, right, or whatever it is, whatever the name. And so technically this name here at this top level here is the name of the deployment, is what it is actually. However, in our main.bicep, we specifically said, hey, automatically use the name of the deployment as the name of the storage account, because that's an input to the name parameter, and then that's referenced down here, right? So again, it just saves us having to supply a storage account name and a deployment name, when in all honesty, we probably want them to be the same thing anyway, because we want to know that this is the deployment that's related to our storage account. However, you may be trying to enforce naming standards within your modules as well, or create naming standards from formulas. So that may not be the case specifically for you. But then typically you wouldn't have a separate name parameter. You would then have components such as environment or application, and then you concatenate those things together. So you might go ahead and do something along the lines of param env is a string, right? And that's a required parameter. And then we might go ahead and do another one, which then is a So what was that?
Location.
Location. We've got location there. Yep. But yes, we could also do something like that. And then we could go ahead and make our name. And so with this here, we can go ahead and use, a little bit hard to see there. So if we would do app and then dash env, right? That would basically go ahead, not that that's valid for a storage account, but we'd basically get that concatenated together from our parameters. Go ahead.
And how would I define that I want dev, test, and prod?
Yeah. Great question. So maybe we only have a certain set of allowed environments, such as dev, TST or test, whichever you like, prod. And then if we went over to our deployment or our test, right, because again, we'll be testing that as well, then we'd go ahead and specify, and it will actually auto-complete it for us, which is pretty awesome, because that sort of saves us time. You'll also notice as well, I didn't call it out previously, I just have one, but there's also, you can also sort of see in the file here that I've also got descriptions. So I've got attributes on my parameters as well. And so if I go ahead within VS Code, then hover over those, right? So if I go ahead and look at my name, hover over it, or when I'm choosing the parameter as well, it will also tell me, you know, this information down here is basically that description. So it also gives me additional information, tells us the type of object, and it might say that it's required as well, right? Cool. And so, yeah, then I could obviously go ahead and deploy this. So in this case here, I'm actually using a Bicep file like a parameter. So strictly speaking, in Bicep, I don't actually need to have a separation between parameter files. I can actually go ahead and just deploy this, deploy Bicep file, or from the CLI, deploy this directly as is. I don't have to have a concept of a separate parameter file. And so I could go ahead and create a parameter file, and I could go ahead and call my my main module down here. But the chances are that really I would probably just do that for our main.bicep instead. The main thing when using Bicep parameter files is you can only target one Bicep file, whereas here technically I can go ahead and have, if I wanted to have storage 2, it's really just a copy and paste job. And then I've got storage 2, right? And that's perfectly fine. When I do that deployment, it'll just deploy all those resources together, right? If I wanted to sort of say, hey, there's a dependency on the virtual network, then all I need to do is just reference a property of the virtual network somewhere. So maybe I was deploying like a private endpoint or something like that, which is again is something commonly that customers might do, right? So we'd just, I'm not going to wire it up, but we'd define a parameter for subnet ID, right? And we'd make that a string, and maybe that's a required parameter. Go back here, we would then go ahead and then specify, hey, let's go ahead and plug in our subnet. So we'd actually then potentially go ahead and maybe we don't define the VNet, maybe we do. Alternatively, because again, it's probably the VNet itself is probably not in this file. It's probably defined in some other file that then the infrastructure team are managing, as opposed to this potentially is my application file, right? I would then go ahead and reference an existing subnet, which would then be of virtual network subnet type, and then it would be an existing one, and I'd specify the VNet, which it could be this VNet or it could be a different VNet. Let's just go ahead and say that's a different VNet for now, and it would be maybe subnet. And then we could basically go ahead and plug in subnet, which is the name that I've used up here, dot ID. And then that would automatically go ahead and obviously plug the resource for that in there. If I specified this as the VNet instead, that would actually also automatically build a dependency chain on that as well. So Azure would know that I needed to deploy the virtual network or the subnet first before it could then go ahead and deploy the storage account. So that's pretty well just automatic. There is a manual way to do that as well, which I think was called out in the chat, that you could go ahead and specifically say, I want to depend on that VNet, right? That's entirely something that you can do, but it's absolutely not required at all, as long as you reference and that resource somewhere else, or reference it by using a property. Go ahead.
That's what I was going to ask.
Yeah.
You don't need to depend on if you actually.
No. Yeah.
But that's not doing anything else, that line, subnet ID line at the bottom, other than defining the dependency. There's no kind of delegation.
It's not in this case because I didn't wire it up, but ideally you would. So if I was doing something like, if we go back over to maybe that one, yeah. By going to something like, let's use APIM because everybody likes APIM. There's a question before about that as well. So obviously APIM, like I said, has a lot of stuff that you can configure in it. But an example would be, in this particular case here, I've exposed a parameter somewhere, which will be subnet ID, right? And then when you specify that parameter, it does actually do something. So we can also go ahead and right click and go, we can go ahead and find all references, right? And then we can go ahead and find that it's used much further down here to basically sort of say, here's my virtual network configuration and here's my subnet resource ID. So in this case, it is consumed, but in terms of referencing it through the dot property like we're doing in the other file, that will automatically build the dependency chain, but it will also pass the value to the module so that then when it actually goes to deploy the APIM, Azure has made sure that then the Azure resource has already deployed. And if the deployment failed as part of a previous step, then it will stop and it won't go that far anyway. But then also it'll pass the value of what the subnet was actually called once it's deployed into the module to then deploy the APIM, so it connects to the right subnet. Yeah. Cool. Let me just double check the chat and also double check how we are going for time. Whoops. Cool. I don't think there's any. Yeah. So, do you recommend using version v1 folder for module for both monorepo and distributed repo patterns, or would you use ACR image tags? So, great question. I'm going to slightly park that because we will actually show that right now. So I will answer it with an example. And so. Basically, if we go ahead and use that. Hello?
Sorry, Benry, sorry to interrupt you.
Yes.
I was new to Azure. I'm a little confused about when we write the ARM templates, the JSON file will be updated usually. And how about this bicep? Is it also updating the JSON, or is there an internal mechanism working out over there? Could you please explain?
Sorry, are you able to just repeat the question? So if you update the bicep file.
Yeah, when we write the ARM templates, the JSON file will be updated. Usually we write it in JSON. And when we write the bicep code, that's also compiled into JSON, right? So when it compiles to JSON, how it could be when we have pre-existing ARM templates and the new bicep code, which we are going to write to automate the configurations and all. So how it works? Is there an internal mechanism how it converted to JSON, and how it would works for both the ARM templates and bicep? I'm a little confused about that. Can you please explain if you have?
Yeah, no worries. Great question. So yeah, so basically when you write bicep code, you don't need to compile it to the main.bicep there, so you don't actually need to compile it. But let me show you and expand on that answer as well. So so I guess you have a few options. One, you could just write bicep code. Two, you could write bicep code and then compile to the JSON code and then deploy that. Or you could write the bicep code and just deploy it natively. So those are probably the primary two options. So I guess if you start moving down bicep, pretty common. Customers don't necessarily have everything bicep day one. So there's two things that they want to be able to do. One, maybe you've already got an ARM template. So let me go over to this repo here. And it just so happens that I do have one of those. Let's go with maybe a data factory, right? Let's go ahead and copy that and jump back over here. So we've got our ARM template. Let's go ahead and put it under, again, it's existing code that's in our environment. Maybe let's go ahead and put that in our modules folder. So let's call it data factory. Oops. V1, right? Or maybe we put it in a separate templates to keep it discrete. In this case here, I'm just going to put it in with everything else. Cool. So we could actually technically consume that in Bicep just like that, right? We actually technically don't need to have any changes to be able to consume it. So if I want to, again, go ahead and consume that as a module, right? And this is going to be my data factory, right? Then, oops, dot slash and modules and probably not find it because it can't find that file, but factory v1 and template.json. Have I done that wrong? Let's just go ahead and just copy that relative path instead. That might.
Storage is full.
Oh, yes, you could be right. Yeah, I think that is correct. Let me move that up. Data factory. Should be able to auto-complete that now. Yeah. Cool. And we can actually go ahead and populate it, right? So we can basically consume it exactly like we could have consumed the Bicep, right? There's no difference because, again, the cool thing about this is that while we've got this new Bicep language, which gives us all these features, under the covers, it's the same thing. So it's fully compatible with what it was previously. So if you've already got ARM templates, you can basically just directly consume them. So that's one option. The other option is we could go ahead and convert, which comes to the other question that we had before, which was how can we go ahead and convert existing code into Bicep code? So there's a Bicep CLI that you can download and install, and it has a number of different options on there. But specifically, the one that we want is called decompile. So decompile. So Bicep decompile, give it a file, right? So if we go ahead and do Bicep decompile, and then we give it a file path, such as this relative path here, then it's not a perfect process. So I guess just be aware of that. It may create some issues. It probably, for most parts, it probably gets 80%, I would say. So typically there is some additional lifting that you need to get it across the line. And it depends. It's getting better. The Bicep team and the community in whole are actively working on it. So each iteration typically gets better, but it's not without necessarily its flaws either. But effectively, in this case here, it only had warnings, which is awesome because now we can basically go to our Bicep code for our data factory, and it's pretty well good to go, right? So that's pretty well it in terms of that. In other cases, again, you'll get a compile issue, and then it will generally just go ahead and still output the file. So it will still try to generate the file, but there may be additional formatting or updates that you need to make to then correct that. Cool. Hopefully that answers the question.
Yes, Benny, thank you very much.
Cool. In terms of, so this would be, again, a case of here's our mono repo. We've got, we're referencing our deployments and our modules in the same repo. So then typically what we will want to do then is actually go ahead and extend on what we were just doing. And there's actually there's an option that we can call via the CLI. So we wouldn't do this like manually or anything like that. We just include this within our CI process. So again, going back to the slides, we had a CI pipeline that effectively goes ahead and calls the publish command, which I missed, which is around here somewhere, publish, right? And then you basically give it a file and tell it where to put it. So we would then basically sort of say, go ahead and publish this to a container registry. And so I've already done this. So in my Azure portal, I have a container registry. And effectively, we have all our modules here. So if we want to go to our APIM, right? And then I guess to the previous question as well, again, we've got version 1 tag, right? So again, depending on what versioning strategy you're using, again, you may not necessarily, V1 by itself may not be enough for your version requirements. I always like to start from that point because again, why overcomplicate something that doesn't need to be complicated? But again, you may find that you need major minor version or possibly patch version as an automated generation in your CI process. But then we can go ahead and target these now, right? So where the magic happens here is basically this one file here called bicep config. And so bicep config is effectively the configuration file for bicep. And it will go ahead and then define aliases that you can define. So you can define whatever you like. I've just defined prod and dev. And then you basically sort of say, where does this dev live? And then you basically give it the container registry, and then you give the path within that container registry. So you'll sort of notice here it's private /bicep /module /dev. So this is called a repository within a container registry. And so you can have a structure here. So you might choose to go ahead and have production modules or dev modules potentially in the same repo, or you could go ahead and have it in separate container registries, right? But you can do that too. So it's sort of up to you on how you structure it. But basically, once you go ahead and define your module and your container registry, then you can actually reference as an alias. This is optional. You can actually just go ahead and put in this full path every single time. I wouldn't recommend doing that, right? Because again, it's additional work that is not required. But instead, what we can go ahead and do is do module, and let me just scroll up slightly for that. Module, and then again, give it a name. So let's do my APIM. And then I would then use basically, you can sort of see there's this BR / environment suffix that then exists now. So I can go ahead, and I think mine are all on dev, I think. Prod, I think they're on prod. And then I can go ahead and do APIM and then V1. So unfortunately, there's no auto completion on this yet. It is a feature that's coming. There is also a public registry, which then allows you to then go ahead and discover all the resources that are published on that registry. That will come to the private registries at some point, but it's not a feature today. But then we can go ahead and do required properties, and then again, the same normal rules apply. So we've got hover descriptions, we can auto-complete on things, we've got our list of parameters that we can populate, and away we go. So instead now, this module, again, it's not in our local code. It's basically stored in that central container of patterns on our container registry, and now our whole organization can use it, right? And then obviously, if we go ahead and update it, then they can obviously get those updates too, right? Yeah, it's then simplifies that whole process. and everybody's using the same thing, and it would come back to that accelerated process. Go ahead.
Just a question, if I was, let's say, playing around in dev and made a V2 version of my Bicep template, and I made like 3 new container storages to work with, if I didn't want that and wanted to roll back, I can't deploy V1 because that obviously won't delete those 3 containers, but how would you roll back a V2 in that scenario?
Yeah, so the question was, say, for example, I had V2 and I deployed a whole bunch of resources out there. How do I then roll back from that? And so I guess the short answer is that today, generally available, there is some limited options. You could go ahead and redeploy V1, the V1 module. Obviously, there's probably a breaking change between V1 and V2. That's why there's a V2. But if you went ahead and sort of said retarget our module from, V2 to V1, right? I would obviously then need to meet whatever parameter requirements and then redeploy it. Generally speaking, for Azure resources, for probably, let's say 70% of cases, that would actually go ahead and update the resource. And then you would now have the 3 storage accounts that you deployed now using the V1 configuration. And, things may work mostly. It depends, really, is the answer. If it was something like a storage account, yes, it probably would, because again, most of that configuration is straightforward. There are a few things such as maybe, as an example, maybe we deployed, I don't know, let's say we deployed a virtual machine and it had 2 disks, and the change in V1 was it only had 1 disk. So now we have a new virtual machine, we'll deploy it out. It'll only see 1 disk now, but technically the disk would still be deployed. It would be just detached from the virtual machine, right? So those things you need to be aware of. In terms of what the future path looks for, there is a public preview for a feature called deployment stacks. And deployment stacks basically then goes ahead and sort of wraps the whole configuration in pretty well a management layer that then knows when it deploys to Azure that then a difference has occurred, and it will give you an option of what do I do with that thing? Do I detach that disk or do I delete the disk now, right? So it gives you that option. So that's a public preview feature that you can potentially start leveraging. But it's actually been in private preview for almost what feels like 2 years. So it's something that's long awaited by the community and has been a pain point, but it is in public preview now and it is coming. Yeah. Cool, great question. Any other questions?
I asked this a bit earlier, I still don't quite understand. So the BR/prod API MV1, when you compile that to the JSON, is that reference is still there? When does that get replaced with the actual Azure definitions and the resources you're creating?
Yeah, so basically the template, so let me, for ease of sake, let me just get rid of everything apart from the module that we referenced. And let me just fill those, right? So we actually might need something in that. But so we've got that. So basically, Bicep will draw in any modules when it actually builds that. So if I wanted to manually build it, I could go ahead and build template, right? And if I go into my main.bicep here, you'll actually see, oh, wait a sec, there's all this stuff that wasn't there before, because this has actually come from the container registry, and this is my code that is part of my published module, right? So basically the answer is it basically merges it all together into a single construct when it builds. But again, I don't need to create JSON files. I can just go ahead and deploy my Bicep file or under the CLI, or I could go ahead and in my DevOps pipeline, which is probably where it's going to happen, just basically go ahead and do the deployment, and then the Azure tooling will automatically do that build.
Later in the process.
Yeah.
Okay.
Yeah. And so probably the call out there is that when it pulls the modules in, it needs to have access to them at that point. So your CI pipeline will probably need access to your container registry to do that.
But not any more after that. Once you build it, doesn't need it.
That's it. Yeah.
It also not open directory, we'll be doing that. We'll actually cache it. So there'll be a .bicep directory, and inside that will be the bicep module from the container as a local device.
Yeah.
So that's
Yeah.
how that's happening.
Yeah.
Yeah, it caches modules locally. Yeah, but obviously in a CI platform, then that may or may not be true. Depends on the CI platform. If you're using a private worker, then probably it will, but it depends on your configuration. If you're using something like the cloud build agents for Azure DevOps or GitHub, it'll be a fresh machine each time, so it'll always download at that point. Yeah. Cool. So let's go back and see what we've got. This one here. Cool. So final tips. I think I've answered all the questions as well. So if I forgot anything, remind me. But I think I answered all the questions that were there. I will go back to the chat in a sec. So open collaboration. So just like any DevOps process, we need open collaboration. But obviously, when you're building patterns across the organization, then the better your open collaboration, the more SMEs you get involved to a degree, right? You obviously would pull in different people as required. Then obviously this, helps mature that across the organization. And then again, we have less cases whereby you've got silos of people building their own thing that then is unstandard and hasn't been through the same rigor, or scenarios where they then go to a design review process and then get blocked for 2 months to address things, right? Version, of course, and also it's an iterative process, right? So you don't have to start with a repository of 100 modules, right? You can start with one module, or you can start with the ARM code that you already have, right? So definitely go ahead and do that. Cool. So in terms of questions and answers, does anybody have any other questions?
No, I haven't got anything else in the chat.
No.
Does Bicep support inheritance?
Does Bicep support inheritance? Is the question.
Like, I might create a module for a storage account, and then I might want to create 3 more storage account modules where I've set some defaults on top of the base storage account. You know what I mean?
Yep. Basically what we can do, I generally don't recommend it as a pattern, but we can go ahead and let me give you an example. So we can go ahead and I'll explain why in a sec. Maybe let's just go ahead and create a global.bicep, right?
Yeah.
And then maybe let's go ahead and then within our storage module, go ahead and pull in main. So let's go ahead and get main from that directory, right? And then we'll just keyboard mash there. And then within main, let's go ahead and then pull in module global, right? And so that's all technically possible. Sure, let's combine there. Oh yeah, module identifier. Okay, so global. So that there. So we can do that, right? The challenge is that then it becomes much harder to manage, right? If we make a downstream change, say example, yeah, I'm already losing track of it, but in storage, we're calling main. If we go ahead and make a change down in storage main, then obviously that potentially like bubbles all the way up. So there's definitely cases where you can do it, and probably it makes complete sense to do it, but you should be careful about how you do that, just because dependency chains then become a complex beast, right? Also, strictly speaking, today, what happens is that when you go ahead and do a module, Azure will separate that into a separate deployment, right? And so it's not really so much of an issue, but if you do it on on a massive pattern scale, it may become an issue, because whenever you kick off a deployment, it typically, takes, you probably watched it, it probably takes 2 or 3 seconds for the most case, and that's just Azure evaluating it. So every deployment you have, you're sort of consuming like 2 or 3 seconds, right? And if that's then one deployment, but then chain 20 deep, then effectively you wasted potentially like 40 seconds, right? So, and then if you do that at a bigger scale, obviously it multiplies. So, so yes, you can do it. Probably the cases where I would suggest doing it is that there's a few like repos out there that Microsoft are building, such as Carmel or called resource modules. You may have leveraged it. Anyway, there's a few GitHub repos out there that have a common set of Bicep modules that you can consume. Obviously, again, being Microsoft, we are trying to cater to all customers. So there may be like 100 parameters there that then you don't actually need, right? So it makes sense to consume that in a module that then is a pattern specific for your organization and opinionated, and then just expose the parameters you want. When you go ahead and publish the module to the Bicep registry, it'll automatically, it won't separate out the deployments, at least yet anyway. I won't consolidate the deployments. It'll keep them as they are, but it will compile it into a single file within the container registry. So it does make it a bit faster, but you still will have some overhead there. So yeah, so you just got to be sensible about it. It absolutely makes sense, but you just need to make sure that you don't create a dependency nightmare as a result of it. Yeah. Cool.
Is that the community registry aligning to any of your reference architectures? So
yes.
Blah, blah, blah. And over here, here's the Bicep repository.
Yep. So the I'll put it up on there for the sake of the recording, and also for people in the room. If you go to, it's called resource modules is the repo. So resource modules, yeah, that's the repository name, but it's basically called Common Azure Resource Modules Library, or abbreviated to CARMEL. But basically, this is based on the cloud adoption framework primarily. So basically, it's aligned to that. They do have quite a few different options in there, so they often won't necessarily, like generally speaking, private endpoints is something that's highly encouraged throughout the cloud adoption framework. So the modules do typically have options for both private endpoints and non-private endpoints. So it is opinionated to a degree, but it's not necessarily hard opinionated. But I guess the consequence of that is it has like lots of parameters. So that's why you typically need to wrap it, right? Yeah. And these modules are also going to be put, they are transitioning their way to that public registry I was mentioning as well. So over time, it'll actually be even easier to consume. At the moment, if you want to consume these, you would then download the GitHub repo and then you'd publish it to your container registry, right? Or consume it in that common patterns library. But over time, they will actually make their way into the public registry once they go through some additional changes and processes and things like that. Go ahead.
I also built a wonderful module for my organizational colleagues to consume. How would I then get some documentation for it?
Sure. So Damien's asked when he's building his lovely Bicep modules, how would he get documentation for that? So yeah, there's a few different ways. You could there is a tool that I built, but does need a little bit of work on it a little while ago. And there's a few other tools out there as well, but it will help you go ahead and build documentation for that. So I would use an open source tool. If you would like to use PS Docs, then go ahead and do that. Currently, it doesn't support Bicep natively though, so you typically have to go ahead and build the ARM template, and then go ahead and then run PS Docs, which let me just go ahead and enable the extension. There's a lot more than I last saw. It's better. Enable. And then I would go ahead and Control-Shift-P and then generate Markdown. And it would then, in a brief moment, I think, we'd give it a path. Oops, that was an accident. Do it again. File, give it a path, and then it should go ahead and pop out a basically a markdown file. So that would be your documentation that then you could go ahead and publish with something like MakeDocs or other markdown publishing tool sets. There's quite a few available out there. Obviously, it depends on how good your descriptions are, right? Obviously, if you leave blank spaces, then that would be a problem. So that's one tool that you have. It's probably, I think it's quite a few people use it, but I'm sure there's others out there. But you know, that's probably my preference, but also I'm biased on that. Cool. In terms of testing as well, again, since we've started, we might as well, I guess, continue as well. So there's also that tool that I mentioned called PS Rule, that then will, so we go ahead and create a, let's go ahead and create a psrule.yaml file and go ahead and just do some configuration. So include modules. Then we can go ahead and save that file. Go ahead and run analysis. And then it will go ahead and make some checks. Actually, I don't need to go ahead and configure one thing there. Configure configuration. And then do bicep file expansion, true. And then it will sort of start picking up. It'll start picking up issues. So if we go ahead and run that again, it'll probably horribly complain because I haven't configured it there. But yeah, basically that's also another tool that we can use from a infrastructure as code and DevOps process perspective as well. So PS Rule goes ahead and checks against the well-architected framework. So it will go ahead and like give you information about how you can secure your environment with enabling security practices, but also things that then tune for cost. Let me actually go ahead and put a proper one in. Let's go back to the config that I already have.
And I don't know if you have one ready to go, Bernie, but are you able to demonstrate the custom policies in your Azure tenancy? Is that too much? It's pretty short.
Sure. So I guess yeah, so there you go. So it's picking up an issue that there's actually a build issue because it's respecting some required params that are actually required by the module but aren't populated, probably because of one of the things that I was doing over here, right? But basically, yeah, so from a policy as rules, so basically what Damien's referring to is that when we're deploying to Azure, then we often have Azure policies that will basically block deployments. So they may go ahead and sort of say, hey, you need to have this tagging standard. And if you don't have that tagging standard, block or require certain security controls such as the MinTLS and various other things. So I guess the goal is actually to go ahead and pull all those policies and bring them all into the coding experience so that then when you go ahead and develop your code, you know about any issues before you actually try to go for peer review or try to deploy that to your environment, right? And so that's the idea. So in terms of PS Rule, like this version here has about 394 or so rules associated with it, which are well-architected rules, so quite comprehensive in itself. But if you wanted to then go ahead and from an Azure perspective, go ahead and pull in some policies. From Azure. Maybe I'll just go ahead and do it. So we can go ahead and export AZ policy assignment data, and then run that command. So it's a PowerShell command, at least currently. So it's an experimental tool at the moment. Context. Okay, so I need to connect to Azure, which I didn't have that planned. Let's go back here and just use the file that I've already exported. Then policy assignment, or maybe one of these simple ones, right? Let's go ahead and grab one of those, throw it in there. So I guess this would be an example of a policy that then you might have in your environment. This actually is actually a structure that's built by that tool, but basically it includes the actual assignment in your hierarchy, plus then the policy itself as one structure. So basically this is like a typical case in terms of that maybe we go ahead and require tags, in this case here, tags on a resource group, right? Pretty common scenario. Instead, so what we can do then is, so we'll see if we get any errors. Again, this is a test tool, so AZ policy assignment data rule assignment data, and then we can go ahead and give it an assignment file of policy, and then it will go ahead and generate effectively a rule that then we can then go ahead and basically go ahead and like actually action on our code. So if we go ahead and copy this here and throw it into our .ps rule folder. Cool. So basically this policy says resource groups must define tags, right? And must specifically define the environment tag. If they don't, then it's no good, right? So if we go to here, and maybe let's just choose maybe our storage one. Let's go ahead and define a resource for a resource group, because you can actually do that as well. So RG, and then this is going to be resource groups, right? So there's that. Required fields, keyboard mash, and location, again, keyboard mash. It is complaining about, okay, so something that I didn't mention before, but is worthwhile calling out now, is that when you go ahead and define a bicep file, it assumes the scope that you want to deploy at is within inside a resource group, right? Because that's most of the time, that's what you're doing, right? However, there's cases where you don't deploy at the resource group scope, you deploy higher. So for example, if you want to deploy a resource group, you actually need to deploy at the subscription scope. Or if you want to deploy policies in your environment, you may need to deploy at a management group scope, or other management groups, or other subscriptions. So again, you've got a few different scopes. So to do that in Bicep, you basically set a target scope, and then Bicep knows. And in this case here, we don't want to do that because we can't do that. So we want to do the subscription scope. Correct. And now it's much happier. So now if we go ahead and run that, then basically we're expecting that then that should fail because we don't have any tags, right? So that's the general concept, but on a broader scale for all your Azure policies. So yeah, that's basically an example, although not quite ready to go on it, but that's basically how it works.
So maybe did you line that up? When you said that was coming and I was looking forward to it.
I think Sam mentioned probably, because Sam works with me on those things.
I think last meetup, the meetup before that was on its way. I'm very excited about that.
Yeah.
I'm very slow at writing PS rule stuff.
Yeah.
So you mentioned scope of subscription. Can you go up and management group? Can you go to the account level, as in role?
As in.
Accounts.
Oh, yeah. So for deployment stuff. Yeah. So that's a good question. Can you create a billing scope in Bicep? I'm not entirely sure, because it sort of sits outside in the maybe not. I haven't tried it, so I can't say. But basically, you can go from so if you're looking at it from a like a tenant perspective, then I can't really see it here, but yeah, we can't really see it here. But in terms of like subscriptions, right? We have basically a subscription scope, and then below that we have resource group scope, but above that we have management groups. And so you can deploy a management group at the tenant scope, right? So you can basically deploy as high as the tenant scope, and then management group, subscription, and then resource group scope. So you can deploy any of those scopes.
Yeah, my motivation was sort of like creating a bicep script for a landing zone or whatever the terminology you want to use.
Yes, you can. Absolutely. Yeah. So specifically on that, there is bicep, ALZ. Or ALZ bicep. I think it's the other way around. Bicep. So there is basically a repo around Azure landing zones, which then does go ahead and deploy. They do have a diagram here somewhere. I think it's this one here, which then basically is bicep end to end as a process, right? And you do need to obviously configure parameter files and stuff like that to make it happen. But basically then it would deploy management groups and subscriptions and stuff like that. There's also separately I always forget what it's called, but let me just go ahead and quickly find it up here in the repo, which is called vending something or other. Yeah, bicep LZ vending. So this is basically the concept of like a vending machine for subscriptions, for Azure subscriptions, right? So yes, that's something that you can also do. So this is more a standard like stamp out of subscriptions, right? So that is also a module that's also available. Yeah. Cool, awesome. Well, we are reasonably over time, so I will park it there. But by all means, reach out to me on LinkedIn or have a chat with me. I will stay around for a little bit longer after the talk. So definitely come up and speak to me. Or if you're catching it online, then ping me on LinkedIn is also fine. So thank you. You've been a great audience tonight. And yeah, definitely look forward to the following sessions at the user group in future months. Thank you.
Wow, thanks. Thank
you.
That was an amazing session. Very, very full. It's awesome. So, and as usual,